Welcome to Introductory Statistics 1. We are now on the final unit, Unit 6, that stands Special Probability Distributions. So at the Unit 6, you're going to begin with Section 1. Section 1, Discrete Uniform Distribution. Now, at the end of this session, you should be able to state the PMF, probability mass function of a discrete uniform distribution, calculate its expected value, and also the variance. Now, with a discrete uniform distribution, it said that a random variable x that assume the values x1, x2 up to the xn, the nth x, with equal probability is said to have a discrete uniform distribution. And this is given by f of n, or f of x such of n equal to 1 over n, and x assume values from 1 to x1, x2 up to xn, and where we should know that n is an integer. So we are saying that the probabilities will be equal, and that's we could determine as a discrete uniform probability or distribution. Now let's maybe work with an example, and then maybe the idea will be very clearer. Example 1. Suppose a fair die toss once. If a fair die is tossed once, then what it means that each element of the sample space, the sample space will be values from 1, 2, 3 up to 6. And each will have a probability 1 on 6. So we're going to have the function or the distribution to be f of x such of 6 will be equal to 1 over n, where x assume values from 1, 2, 3 up to 6. Now look at theorem. The mean and the variance of the discrete uniform distribution of the function f of x such n are, so the mean as the expected value will be n plus 1 all on 2, and the variance will be the expression n plus 1 multiply another expression n minus 1 all on 12. And that is a theorem. So let's take another example, and referring back to example 1, if you're asked to find the mean and the variance of the distribution, where we said that a die is tossed once, what would have been the mean and the variance? Look at the solution. Well, since a die is tossed once, it had number of, or n will be equal to 6 because it has 6 number of sides. So in a simple sentence, the expectation is n plus 1 over 2. And where we have our n to be 6, we're going to have 6 plus 1 over 2. That will give us 7 on 2. And of course, the variance, as we're giving us n plus 1 multiplied by n minus 1 all on 12. That will give us 6 plus 1 multiplying the expression 6 minus 1. And that will give us 7 times 5, that's 35 all on 12. So our variance will be equal to 35 on 12. So simple, right? I hope you can work on more examples. Thank you very much.